Hello and welcome to this video. Hello and welcome to the next video in this little series on moles. What we're going to be looking at in this video is we're going to be looking at reacting masses. And what's that all about? Well, that's all about using moles in calculations where you're given a reaction. Okay, so just to start things off, let's assume that we've got a reaction x goes to y. Okay, we're just looking at this reaction here, x goes to y. There are sort of two kinds of questions that you could be asked with regards to moles. The first is sort of how much of x is needed to make 10 grams of y. And the other kind of question you could be asked is, well, how much of y can be made from 10 grams of x? Those are sort of the two style of questions. Now, what we're going to cover in this video is really, really important because actually it forms a foundation for all sorts of different mole calculations in the future, whether that be percentage yield, as just one example of many. Okay, but it has lots and lots of really useful applications. Okay, so the best way of talking about this is using an example. So let's use an example straight away to talk about what this reacting masses is. Okay, so let's take the example of calcium carbonate. Okay, and I'm going to basically heat calcium carbonate through a process of thermal decomposition to produce carbon dioxide and calcium oxide. Using this example, let's see where reacting masses fits in. So, let's start off with saying we've got 100 grams of calcium carbonate. Now, what I want to know is what mass of carbon dioxide and what mass of calcium oxide could be made from 100 grams of calcium carbonate. Now, the first step, okay, to approaching any kind of reacting masses question is to draw on the scaffolding. Okay, now I'm going to just write this scaffolding. So what is the scaffolding that I need to do a reacting masses question? Well, all you need to do is you just need to draw a downwards arrow to here, okay, and a cross arrow to the substance you're interested in. So let's say, for example, we're just interested in carbon dioxide to start with, and then an up arrow to the substance that you're interested in. Now, this doesn't have to be sort of from a reactant to a product. It could be a reactant to another reactant. So how much of X will react with oxygen to form X oxide could be the question. But this is just the scaffolding that you require. Now, what else do you need? Well, you need to write M, 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 R. M, 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 R. Well, what do each of these stand for? Well, the first one is mass. The second one is MR, the third is moles, and last but not least we have ratios. Okay, so that's what that all stands for. So how do we use this framework? Okay, well I'm going to change my colour. What should I go for? Let's go for a darker green. Well, should we go? Well, let's go for a lighter blue. So what I need to do, okay, is I need to now fill in this information. So the MR is simply the MR of our calcium carbonate. So the way in which we would work that out, and these are the kind of things that you want to make sure you're doing, unless it's provided to you, is work out the MR of this. So the calcium is 40 plus the 12 from the carbon atom plus 16 multiplied by 3. Okay, now that all equals a nice round 100. Okay, so my MR of my calcium carbonate is 100. That's the next thing I need to write. Okay, now we need to work out the moles. Now this is where our scaffolding comes in. If we're coming down with our scaffolding in this direction, what we always do is we divide. Okay, so in order to find out the moles, I just simply divide my mass by my MR, which gives me my moles, 1. Okay. We then move on to the ratios bit. Okay, and the ratios is where we look at the big numbers in front of things. Okay, so the big numbers in front are important. So what we do is we look at the substance that we're basically doing the calculation of and the one that we're interested in, and we look at the big numbers in front of them. Now the absence of the big number means that the number is 1. So here we have the number 1, and here we have the number 1. So that means that our ratio is going to be a 1-to-1 ratio. So when we come to writing the moles over here, following our arrow across, because it's a 1-to-1 ratio, I can write a 1 in here. The next thing I need to do is I need to write in the MR of my carbon dioxide. So the MR of carbon dioxide is 12 plus 16 times 2, okay, which is 44. So I write in my 44 here, and I use my scaffolding. Now this time I'm going upwards. And when I'm going upwards, I multiply things together. So 44 multiplied by 1. So therefore, the mass of carbon dioxide that would be made, okay, if I burnt 100 grams of calcium carbonate is 100. If I burnt 100 grams of calcium carbonate, I would make 44 grams of carbon dioxide. So using the scaffolding, I can go along and follow that. Now, if I wanted to extend this to the calcium carbonate, all I would need to do is just extend out, my calcium. If I wanted to extend this out to find out how much calcium oxide I would make from my calcium carbonate, I can just extend out my arrow a little bit further and just draw the same scaffolding and utilize the same method. So from here, I can look at my ratio. So my ratio all the way across is 1 to 1. Okay, so again, it would be a 1 to 1 ratio because this arrow is going all the way across. So I have a 1 in here. Or conversely, I could use this one here. Still 1 to 1. I then write in my mass of calcium oxide, okay, which is 56. Okay, so 56. And then I would multiply those together, which gives me 56 grams. Now, this highlights a really, really important thing. Okay, now if we look, on the left-hand side, we've got 100 grams. On the right-hand side, we also have 100 grams. Okay, the right-hand side equals 100 grams, as does the left-hand side. Now that is because of the rule of conservation of mass. And this rule is why the reacting masses calculations work. Okay, we just do it via moles, okay, because that helps us with our calculations, especially when they get a little bit more complicated. So, and it allows us to work out what ratios things are made. So that's reacting masses. Should we ever go to a question? I knew as soon as I asked you whether you wanted to do a question, you'd be like, yeah, of course we want to do a question. That's why we're here. So let's do one. Here we go. Magnesium reacts with hydrochloric acid as shown in the equation. Okay, magnesium plus hydrochloric acid goes to magnesium chloride and hydrogen. Now the question is this. How much hydrogen is produced when 60.75 grams of magnesium is reacted with excess hydrochloric acid? Now, a couple of pointers just on this question. First thing, what does this word mean? Well, excess. Excess just means I've got absolutely tons of hydrochloric acid. We do not need to worry about the amount of hydrochloric acid when it comes to this calculation. The second thing is that whenever you've got these kind of questions, you will either be given the relative atomic masses of the elements present, like you have been here, or you would be using the sheet of data that you've got with the exam to actually find out what the relative atomic masses of those elements are. So there will possibly be a little bit of calculations of relative formula masses during this calculation. So I'm going to give you the answer in two parts. My first part is just going to provide you with the scaffolding and what I'd be highlighting in the question, and then you can have a go at the calculation if you want that little bit of extra help, or just carry straight on and do the calculation straight away, and then I'll be giving that back in the second part of feedback. So that's enough from me. Over to you, have a go, pause the video, see you in a minute. So part number one, let's look at the scaffolding side of things and what we actually need to get from the question. So what we need to get from the question first off is the equation, and we would write that down. It just makes it so much easier as part of your working to write it down, and especially if you're using this scaffolding method, it's really, really good to just show every single step. So what information do I have? Well, I know I've got excess hydrochloric acid, so I don't need to worry about that. I've got 60.75 grams of my magnesium, so I can write in 60.75 grams of magnesium into here. Second thing that I can write down, how much hydrogen? Okay, so I'm actually going to write a question mark there because that's what I'm interested in. What I can also do is I can also write in my actual scaffolding part. So I'm going to draw in my arrows, one going all the way across to hydrogen and then all the way up. I then can write in my letters. So I've got M, 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 R. So that's my scaffolding. Okay, that's everything that the question has given me so that I can now carry on with the calculation. That's going to be part two of the feedback. So pause the video again if you wanted that little bit of extra help, and then have a go at the calculation. So calculation time. Let's see how we've done. Here's my scaffolding, all ready to go. First thing I've got to write in is I've got to write in my MR of my magnesium. Okay, so that's going to be 24.3. And I know that because it's written in the question. It's given to me just here. Okay. The second thing is I've got to work out how many moles that is. Now remember, we're going down with our scaffolding, so this means we divide these two numbers. If I divide those two numbers, it gives me 2.5 moles. We then look at the ratios. The ratios is big numbers in front of things. So if I've got big numbers in front of things, okay, here I've got a 1, here I've got a 1. So therefore my ratio is going to be a 1-to-1 ratio. So therefore, I'm going to have 2.5 moles of hydrogen being made. The next bit that's important, well, my MR of hydrogen. Remember, it's H2. So H2 is 2 multiplied by 1. So it's going to have a mass of 2. Last but by no means least, I can work out my mass of hydrogen being made. Okay, and remember, I'm going up here, so I have to multiply these two numbers together. It's 2 multiplied by 2.5, which equals 5 almighty grams of hydrogen. So the answer to this question is 5 grams of hydrogen. Let's have another go at another question. Right, so here's another question. I said there are sort of multiple ways that things could be asked. I kept it the same reaction, so magnesium reacts with hydrochloric acid as shown. This time the question is slightly different. How much hydrochloric acid is needed to react with 48.6 grams of magnesium? So this is sort of assuming like we want all of the magnesium to react. How much hydrochloric acid do we need? So again, I'll do the same kind of feedback. I'll give a first set where I'll look at the scaffolding and what's in the question. And the second thing I'll do is do the whole calculation. So, over to you. Have a go. So, let's look at the information that's in the question. Step number 1 would have been to write out the equation. I already had it written out from the last equation, so that's fine. So, what else is in this question? Well, the first thing that I've got is I've got 48.6 grams of magnesium, and I'm after the answer for my hydrochloric acid. Okay, so from here, okay, we're going to draw in my scaffolding, arrow going down, arrow going across, and an arrow going up. Okay, the second thing I'll just highlight is when I've said how much, it's what mass. Okay, so when we're looking at this here, okay, this is the scaffolding I've got, exactly the same, M, 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 and R. So this is all that I need. Okay, information is up here. So that's the scaffolding part. See if you can have a go at the calculation bit. So now on to the calculation bit. First thing we know, we've got 48.6 grams of magnesium. We know that the MR of the magnesium is 24.3. We're going down, so we divide. Okay, so how many moles have we got? Well, we've got 2 moles. Now this is the bit where it's slightly different. On to the ratios. We're looking at the big numbers in front of things. So we know that we've got 1 to 2. So this time when we're looking at our ratios, if we've got 2 moles here and it's a 1 to 2 ratio, we've got to multiply this 2 by 2. So therefore we're going to have 4 moles of HCl. Okay, now we need to fill in the MR for HCl. So we've got to work that out. Well, we've got H, which is 1, and we've got Cl, which is 35.5. So therefore we've got a mass of 36.5. And I can write that in. Now remember, we're going upwards, so this time we multiply these two together. Okay, so when I come to my answer, what I'm looking at is I'm looking at 36.5 multiplied by 4, okay, which equals 146 grams. Okay, so there we go, that's our answer. Now, when it comes to reacting masses, the questions will all be around this kind of theme. Okay, as I said right at the beginning, how much of X is needed to react with Y to form so much of this other stuff, or how much of this other stuff can be made from X and Y. Okay, so a couple of new words, a couple of new things, but the main thing you really need to get from this is that scaffolding method, and hopefully with a couple of examples you're feeling a little bit more on top of that. But we're going to be revisiting this in future videos, and certainly in the next video when we're looking at yields, okay, we're going to be talking about this. When we talk about concentrations, we're going to be talking about this. So it should be a really useful lesson. Maybe rewatch it if you haven't quite got the hang of it. Okay, but this is a theme that we'll be using. Okay, so as always, thank you very much for watching. Please like the video, subscribe to the channel if you haven't already, Really appreciate your support, but continue to watch the videos in this playlist, and I hope they are of some use to you. So as always, thank you very much for watching, and I'll catch you next time.